Hi guys, here's a video on multiplying and dividing rational expressions. We're going to start off with multiplying basic fractions. That way we can get the process down before we start multiplying more complicated rational expressions. So the first thing I'm going to do is I'm going to rewrite both the numerator and the denominator of both terms as a product of their factors. So 10, if you break it down into a product, would be 2 times 5. And 6 would be 2 times 3. I'm going to do the same thing with the other side. 21 would be 3 times 7, and 25 would be 5 times 5. Now my second step is to cancel out common factors. Remember, when you're canceling two expressions that are being multiplied, you can either cancel up and down. So like in this case, my 2 and 2 would cancel out, because 2 divided by 2 is really just 1. And you can also cross cancel. So you'll see here that I have a 3 and a 3. So these can cancel out as well. So I'm going to cancel everything out that I can. I'm almost done. I can also cancel 1 5 from my left side fraction and 1 5 from the denominator of my right side fraction. So really the only thing that I'm left with after I canceled was this 7 and 5. So your third and final step is to multiply anything that's left. Now since I really only have a 7 and a 5 left, this would really be like 7 times 1 and 5 times 1, which would just end up being 7 over 5. Let's take a look at the next one. I'm going to do the same exact process here, even though these are rational expressions, meaning they have variables in them. So I'm going to start off by rewriting everything as products of their factors. So 16 here would be 4 times 4. And remember, x to the third is really x times itself 3 times. And I'm going to do the same thing in the denominator. 5 doesn't really have any other factors because 5 is a prime number, so I'm just going to leave this as 5. And then y to the 9th is y times itself 9 times. This is pretty tedious to do it this way, but I'm going to start off by doing it this way until we can kind of get the hang of it. And then maybe as you get better, you'll be able to skip this step. So my right side fraction, I have x to the 5th, which is x times itself 5 times, and y to the 8th, which would be y times itself 8 times. And my denominator, 80. So I have a lot of different options here with the 80, because 80 does have a lot of different factors. You'll see that I have 2 4s in the top left corner here. I have 4 times 4 times x times x times x. So it's a good idea to maybe write the 80 as a product of 4 and something else, and that maybe that will help me cancel. So 80 would be 4 times 20. And then I have x to the third, x to the third, and just a y. Now remember, I can cancel anything up and down or diagonally. So I'm going to start off, I can't cancel either of the 4's on the left with the 5 in the denominator, but I can cancel 1 4 here and 1 4 here. I can cancel, I have 2 x's down here, which means I can cancel 2 x's up here because those would be diagonal from each other. Oh, sorry, I have 3 x's, so all 3 of these cancel. I thought my x looked like a y. So these are all gone now. Now you'll see I have 8. I can cancel this y with one of these 8 y's. And then I have 9 y's on the left side, and I have 7 y's left. So each one of these is going to cancel with one that's diagonal from it. So I'm going to kind of go one at a time, crossing things out. And what I'm left with I have a 4 in the top left, and then a 5, and I have 2 y's. And then on the right side, I have 1, 2, 3, 4, 5 x's. And then I have a 20. Now you'll also notice that 20 here is 4 times 5. So I can break this down even further. And now I can cancel a little bit more. This 4 will cancel with this 4. Now there's no more x's or y's that will cancel out though. So I'm just going to now rewrite my answer a little bit neater. So I'm left with 5 x's in my numerator. So x times itself 5 times would be x to the 5th. And then my denominator, I have this 5 and this 5. So 5 times 5 would be 25. And then I have 2 y's, so that will give me y squared. Let's try another one. Oops. So now we're getting a little more complicated, but it's the same process. I'm going to rewrite my numerator and denominator as a product of their factors. Now that word is telling me that I'm going to have to factor, so our factoring skills are very important here. So x minus 3 doesn't factor, so I'm going to leave that. And then my denominator, 2x minus 8, they have a GCF of 2. So I'm going to factor out a 2 and leave it as x minus 4. Now on the right side, I have 6x squared and 96. They have a GCF of 6. And you'll notice on the bottom, x squared minus 9, this is a difference of squares. So x squared minus 9 factors into x minus 3 and x plus 3. You also might notice that this x squared minus 16 is also a difference of squares because x squared is a perfect square and so is 16. So before I move on, I'm going to rewrite that too. I'm just going to leave my 6 on the outside. X minus 4, x plus 4, and then my denominator, I have x minus 3, x plus 3. And now I'm going to look to cancel either up and down or diagonally. So you'll see that I have an x minus 3 and an x minus 3, so those would cancel. And an x minus 4 and an x minus 4, so those will cancel. Now I also have a 2 and a 6. Remember, 6 is just 3 times 2, so I can cancel this 2 with this 2, and I would just be left with this 3. I'm going to look to see if I can cancel anything else. The x plus 4 and the x plus 3 don't cancel because they're not the same term. And almost everything else is crossed out. So at this point, I'm just going to rewrite my answer a little bit cleaned up. I have my 3. And then in my numerator, all I'm left with is x plus 4, and my denominator, what I'm left with is x plus 3. So you can either leave it like that, or you can distribute this 3 to make it 3x plus 12 over x plus 3. So another example here, same idea. You'll notice that on the right side my term is x squared minus 10x plus 21. But remember that the denominator of any value is really just 1. So if you prefer to write that 1 there to make them both fractions, go for it. So the first thing I'm going to do is rewrite my numerator and denominator as a product of factors, meaning I'm going to factor everything that I can. So in my first numerator on the left, I have a GCF of 2, so I'm going to pull that out. So I have x squared minus 1. And my denominator, I can factor into 2 binomials. I know that because it's a quadratic trinomial. So I'm going to have x squared, well, not x squared, x, an x, which would, when I multiply them back, would give me x squared. And now I need 2 numbers that multiply to be 7 and add to be 6. So that would be 7 and 1. And since I want the 6 to be negative, I'm going to make my 7 negative and my 1 positive. If you forget how to factor a trinomial, it might be a good idea to go back and watch the videos from topic 2 in the first marking period on factoring trinomials. So now I'm going to factor my second one. They have to multiply to 21 and add to be negative 10, so that would be negative 7 and negative 3. I can factor a little bit more because in the top left I have x squared minus 1, which is a difference of squares. So that would factor into x minus 1 and x plus 1. Not equals, sorry, times. And now I'm going to cancel. I'm going to try to cross cancel or cancel up and down. So here I have plus x plus 1 and x plus 1, so those will cancel. And then diagonally I have x minus 7 and x minus 7. And now I'm just going to see if anything else will cancel. It won't. And I'm going to multiply now straight across. So I have 2, x minus 1, x minus 3. And I'm going to multiply this out. I'm going to use the FOIL method. Remember, first, outer, inner, last. And I'm going to leave the 2 to multiply back at the end. So first, x squared, my outer would be minus 3x, inner would be minus x, last would be 3. Now I'm going to combine my like terms. And now I'm going to distribute my 2. We also want to talk about dividing rational expressions. It's pretty similar to multiplying rational expressions, except I have a different first step. The first thing I'm going to do when I'm dividing two rational expressions is to rewrite my division problem as a multiplication problem. Remember that division of fractions is the same as multiplying by the reciprocal. So I can rewrite this problem as 2xyz over x squared times z squared. Sorry, my handwriting's a little sloppy. It's hard to write on this. And then times the reciprocal, 3xz over 6y cubed. And now I'm just going to use the same process as multiplying rational expressions. I'm going to rewrite everything as a product of its factors. So 2xyz, that's already in its prime factorization. X squared would be x times x, and z squared would be z times z. 3xz, I can't break that down anymore. 6 would be 2 times 3, and then y cubed, y times y times y. And now I'm going to look to cancel either up and down or diagonally. I'm going to cross out as I go. So this 3 I can cancel with one of these 3's, and the 2 will cancel diagonally also. I can cancel 1x in the numerator on the left side with 1x in the denominator on the left side, and 1z with 1z. Let's also look to cancel diagonally. You'll see in the top right I have this x, which will cancel with an x in the bottom left, and then the z in the top right will cancel with the z in the bottom left, and then the y in the top left will cancel with one of the y's on the bottom right. So now let's see what I have left. Almost nothing. Everything in my numerators has canceled, which means that my numerator is just going to be 1. And almost everything in my denominators is canceled except y times y, which would be y squared. Can't get that too. There we go. Oops. Let's try another one. So again, the first thing I'm going to do is rewrite it as a multiplication problem. So I have x squared plus 6x minus 27. I'll make it over 1. And then times the reciprocal, which would be x plus 5 in the numerator, and then 3x squared plus 27x. Now I'm going to rewrite as a product of factors, which means I need to factor this. So 27, that would be 9 and 3. To make it a positive 6x, my 9 would be positive, my 3 would be negative. Oops. Times. I have x plus 5 in my numerator. And then my denominator here, I can factor out a 3x, which would leave me with x plus 9. And then let's see what cancels here. I have this x plus 9 will cancel with this x plus 9, and that's pretty much it. Nothing else cancels in this one. So now I'm just going to multiply it back. I have x minus 3 times x plus 5. And again, I'm going to use FOIL. First, x squared. Outer would be 5x. Inner would be negative 3x. And last would be minus 15. When I combine my like terms, I'd have x squared plus 2x minus 15. And let's try one more. This one is a little more complicated, but it's just combining the two things that we've learned, dividing and multiplying rational expressions. So I'm going to first rewrite it as multiplication, all multiplication, times the reciprocal here. And now I'm going to rewrite it as a product of factors, which means I need to factor that middle term, the numerator and the denominator. So 12, that's 4 times 3, which will give me x plus 4, x plus 3. My denominator, I need to multiply to 30 and add to 11, which would be 6 and 5. Since it's positive 30 but negative 11, that means both of these terms are going to be minus. And now I'm going to cancel either up and down or diagonally. So I have x minus 5 and x minus 5, x minus 6 and x minus 6. Oh, and my numerator, my middle term here, doesn't go away at all. That's really all I'm left with. So I can multiply that back. Since I just factored it, though, I know it should multiply back to x squared plus 7x plus 12. And that's multiplying and dividing rational expressions.